So I'm going to share here. So that's pretty much the slides that we'll be using. Just let me know, Pooja, if you guys are now seeing the slides because I can't see anything here in the Teams screen.
Yeah, I can see your slides. It's visible.
All right. So as you saw, it's very straightforward. You only open the file, click on render, and you have the slides to the presentation. So we can continue right now to presentation. So who am I? I am Federico Alegria. I am part of the Psych Club. I'm a researcher in social science, and I'm very interested in the study of the visual culture. So eventually, visual communication and data visualization hit me and became a thing. And what we'll be covering in this closure session of the workshop, it's a rather different approach towards data visualization, and it is um, possible thanks to ggplot, something that I'm very sure you have already heard before, thanks to our folks. So things that we are going to be learning here, it's three main topics. First, about visual decisions amidst basic data characteristics that you already know from data. So it's like this mindset of, okay, I want my data to be shown in this way. I want to tell a story through this type of graph. What data do I need? So R makes it very easy for us with data structures. We're also going to be learn about the layered structure of the grammar of graphics, which is how Hadley Wickham coined the term for the framework that it's behind ggplot, and a little bit of a fun fact about ggplot, and also some gifts for you to, keep you motivated, because I know that coming from SPSS or any other graphic interface solution, it's very hard. But I come from SPSS, then I switched to Stata, and then now I switched to R because it gives me just so much freedom for the stories that I want to tell with my research. But first, you need to consider this, and it's that ggplot and other very useful packages come from this core package that it's called the tidyverse. I'm sure that you might have already heard about the tidyverse, or maybe not. I'm not sure about that. But when you run this little command, you call into to install the tidyverse, and that's it. You have it already installed in your computer or in the cloud-based, as I tend to use a lot the cloud-based of RStudio because it allows me to play with unknown libraries and stuff. So the tidyverse comes with a lot of stuff, including dplyr, which is very useful, and ggplot, and many datasets, including the Star Wars dataset. Sorry about that. I really like this dataset, not just for the fandom of Star Wars, or because it's very cool to see your character names printed out in R, but because it really resembles what data in social sciences usually look like. So you have some character values that you know that are qualities of data. We have integers, we have numbers or doubles as are called it. Like I think in SPSS it's called floating, and here it's double. So it's, numbers with decimals pretty much, and other characteristics as well. So it's a very fun data set for you to play around and start doing a lot of things with this tiny data set thanks to ggplot. So in the slides, you are going to find the code over here. You just click in this callout and you'll have the code for reproducing the exact same thing that you are watching on my screen. So if you run this code right now, you can avoid that because we're centering the slides, but you can run that and you'll have it after installing ggplot, of course. Here's a little trick for you guys if you wanna just print the name of the variables, because sometimes this looks a little bit cluttered to like spot the variable names. So if you only want them just to copy paste it or whatever, you can run this little chunk of code that you'll find here. And what it does is just takes the heading of the dataset and prints it in this format. So if you already saw, data transformation is possible even though we are not assigning new objects. This is what is called wrangling, and it's a very useful skill for data science in general. So along with wrangling, like exploring data, basically, visualization is a central component of exploratory data analysis, also known as EDA, which is this fun and sometimes tedious part of dealing with data, preparing data, and going back and forth, exploring for any pattern, any insight, anything that tells us that we're in the right path in our research, because we need to see this ecosystem aligned with our overall workflow in the social sciences. So for data exploration or EDA, our code allows us to bridge wrangling and visualization in a very seamless way, thanks to the pipe operators, where if you click here in the slides, you're going to be forwarded to the documentation, and there you'll find more stuff about the pipe operators. But basically, you need to understand the pipe operators as and then. So, for example, here, I select my data structure, the Star Wars dataset. I call the original package just for you to see where these functions are coming from, which are not coming from ggplot right now. So we select the dataset, and then we slice the header, and then we glimpse it, or we print this little nice summary. So the pipe operator does that. It's going to take whatever is on the left, it's going to pipe it in to whatever is on the right. So I select my dataset, and then I slice it, and then I glimpse it. So that's what you need to know about the pipe operator. But once we reach ggplot in our code, because, oh, sorry about that, but I barely rely on producing objects, as you'll see in the code that we're going to review in a moment. But yeah, I tend to come from my data set and slowly going into the visualization. So once we reach this ggplot command, we're going to switch to another place in our minds. We're going to switch to a layered structure. This layered structure of the grammar of graphics that Hadley Wickham says in his book, which is the reference for these slides. But first, we have a little pieces of code for you to reproduce after this session, or maybe tomorrow, in which you are going to just paste, like this command into your console, into your R console, and you are going to click on it, just like this. I'm going to show you. So I'm going to copy. Then I come here to my RStudio. I just paste it. So the margins are too large. That means that my window is just too tight for R. And then you get it. So very easy. Continue with the presentation. So you'll be grabbing each line of code and reproducing them in your, oh, damn, I clicked on the function. Sorry about that. Back to the slides. So if you click on the function, you are going to be drawn to the documentation, I think. So each line you can copy, paste it, and then reproduce it on your side. So as I was already telling you about this layer structure, like once we reach the ggplot function, we need to start thinking in layers. And this might be very daunting because you are seeing so many layers, but you only need 3. You don't need all the layers that ggplot's giving us. But I'm going to tell you about the most commonly used layers, the ones that I use the most, which are 5. Data is pretty much required. You need to give ggplot the data where you are trying to pull your variables from. So in this case, it will be, Star Wars. Then the aesthetics, which tend to map the variables that we are interested in visualizing. So it's going to describe how these variables should be treated, like X or Y, or maybe for colors, or maybe for faceting, which is like grouping variables or multiple graphs, I'm sorry, in a single figure. Then we have the geoms or the geometrics, and this one is going to be the most familiar for you because it refers to the plot types. So geom bar is for bar plot, or geom hist is for histograms, geom box plot is for box plots, and so on. So geom is going to introduce us to the graph itself. There's another one. Oh, these 3 are the most basic that you need to produce something, even the most raw graph. And then if you want to use your graph to tell a better story, you can use the labs, which is the labels. It's for controlling the display information, like headings or axis values. And here's where R really excels, because it allows us to change pretty much anything in our graphs. And sometimes perhaps we don't want to do something so graphic design, perhaps, but we do need to say, hey, I want you to draw your attention to this part of the graph. So labels allow us to do something like that. And themes is like pre-install themes functions for you to, reproducing your graph in a different way, or a little bit more visual, if you wished. So here I'm coming from the same data set, the Star Wars data set. And here the logic is this one. I'm calling the data set, which is the Star Wars data set, and then with the pipe operator, I'm piping it over to ggplot. You do not need to type ggplot point, and then the function. This is only used for like tutorial purposes, for you guys to see where the ggplot lives in terms of packages. So data and then ggplot. And then I'm going to define my first aesthetic, which is how data is going to be treated. So if you remember from this example, we had a variable called homeworld, and homeworld is for the planets, like Tatooine, Naboo, and all the planets that we know from Star Wars. So imagine that you're interested in seeing how scattered these characters have been from territories, like thinking a little bit in social science terms. So I'm going to use the homeworld variable as my x value because I want to see the distribution or the count for all these characteristics of the homeworld variable, excuse me. And then I'm going to define, or see that we use a plus sign because that's how ggplot is designed. And then I'm going to add another layer, and this layer is going to be the geom bar. And the geom bar produces, a bar plot, but it's a little bit hard to read, don't you think? It's like there are a lot of values that I don't need, or maybe I'm not that interested because they are like at the one level, like the unique occurrence level. So I'm gonna filter those out, and I'm gonna center only in those that mark a count greater than 1. So in this chunk, what you'll find, chunk is what we call code. So yeah, in this code chunk, you're going to find that we have the data, the Star Wars data, and then I'm pipetting to some functions of the dplyr package, which is count. I want to count how much of the characters, how many of the characters are scattered in the planets. So, and then I want to filter those that count greater than 1. And I'm also going to tell R to don't show me any values because there are some missing values in this data set. That's what I like about this data set, that it behaves like something from the social sciences. It has any values. So we're going to omit those. And after wrangling our data, we are piping this like shorter version of our data to ggplot. So if we didn't tell R this, what it does, and you can try that at home, simply by commenting this, like if you add this hashtag in front of this line of code, you are not going to produce this NA omit instruction, and it's going to show another bar here with the NA values, and it looks a little bit sloppy, So we tend to omit those NA values, and once we have our data the way we want it, we pipe it through the ggplot. So the x value is still going to be homework, but another value, the y value, is going to be pulled from this n that we told R from the count. Because count, what does is that it produces a new variable called n, which has the count, and now we're filtering n greater than 1, and here we're calling n again, to visualize the counts. And then the geom bar, and you can follow this link that I've left here in the comments for you to get a glimpse of all the stat functions that you can give for you to produce bars, because there are a lot of kinds of bars that you can print. Here we're printing counts, but you can also print percentages, or like from 0 to 1 and the proportion. You can do that as well with another stat. So it requires being curious to look into the documentation, but it's a very useful skill. I don't know if my colleagues have already told you about that, but looking into the documentation is a must skill when using R. So as you can see, this produces a much friendlier yet raw plot. Raw because it's quick. This is not something that you maybe want to publish elsewhere. We'll reach to publishing graphics in a moment. Oh, here's another example. Thanks, Luigi. It's what about combined plots? You can combine plots in a single figure thanks to the patchwork package, which allows us to like create a grid of images or graphs. Sometimes it's more useful to have a side-by-side comparison with one variable in one place and then the other one. But there are some minimal things that you should know before attempting to tell something with data. And as you might have already guessed, not all data is reviewed in the same way. There are categorical values, and these are phenomenal for bar plots, but there are also metric values that are not so good with bar plots. We also have time series. Time should be treated like it's very weird to deal with time because it mixes like the categorical nature of categorical variables, because one time can only be like registered once, so it's like unique, but it also behaves like a number. So it's very interesting and complex at the same time. But given this, some data is better suited for a certain type of visualization. So we're going to start with which geons are good for categorical data. And as you already know, categorical data, which is not qualitative data like text, it's more like something you can measure. So It's very well suited for data because you can count instances, and sometimes you can use them for surveys or even leader scales, excuse me. And these categorical data are sometimes aided by integers. Like we can use number 1 to represent Tatooine in our Star Wars dataset, number 2 for Naboo, and so on. So we can use numbers to assign certain values, like we do when building dataset in SPSS. So categorical data, it's better suited for certain type of geoms, like geom bar, which produces bar plots, geom segment, which produces like slim lines resembling bars. Geom lollipop is a favorite of mine. It's like a mix between the segment and a point. You are going to see one in a moment. And the tree map it's a better solution for the pie, like the pie charts, because pie charts after 3 instances of a variable becomes very confusing, to tell if that proportion is greater than this one, or but here this package allows us to see it in a better fashion. You're going to find in the slides a link to my GitHub repository where you can copy and paste the R code for producing all of these graphs. That's another very useful skill, to learn how to navigate through GitHub repositories for reproducing stuff somebody else have done in the past, something that it's very familiar to science if you think about it. This is a better example of the histogram that I produced earlier. And here is the code for reproducing it. Up to here, up to geom bar identity, excuse me, it's familiar to you. It's what we produced in the previous histogram. Then I added another layer, as you can see, which is the labs. And labs allows us to print, text anywhere in the graph. So I want to use a title, we're seeing homeworld distribution across the Star Wars universe, and a subtitle among characters from the Star Wars saga. So that's the subtitle. You can add a caption as well for further explanations. Data has been filtered to show counts greater than 1. And in the X values, homeworlds, and I left the Y in a blank because I think it's obvious, that we are looking at a count. And then I added, another layer, the theme minimal. And because I love the Consolos font, I also said here, but you can print any other font that you want. You can have fun changing all of these attributes so you can see how the graph changes. Perhaps you can filter for greater than 2 and you are going to see less bars and so on. So after running this, as you can see, I don't like producing separated objects. It's more like a single command, long command, but a single command for reproducing my stuff. So here we have the graph. It looks a little bit better than the previous one. And we have some information as well that's telling us what we are seeing here, what we are having here in front of us. There are a lot of different graphs that we can make with data. And here is a very useful resource for you guys to follow. Here you can select, maybe you're interested in a box plot, and you click on the box plot, and it's going to show you documentation, like R related documentation, and also some examples for you to reproduce, code examples, and a lot of stuff. So we also have metric data. And unlike categorical data, metric data is well suited for dealing with quantities by illustrating dispersion and distribution via the use of numbers. Like metric, and doubles, and integers as well. So numbers with decimals and integers. And which kind of graph for this? Like box plot shows distribution, the geom point, which is what we call the scatter plot, the geom violin, the geom ridges. There are a lot of other different geoms that we can use for showing metric data. So you can follow. You're welcome. Yeah. And here we can follow this link, and like if you want to reproduce that scatter plot, which is a model that I made last year, and here it's a little bit more good looking graph. Actually, let me see, open. I don't know why it renders like which with the letters a little bit cluttered, but the original image, it's, if you reproduce it, because you can do here, it's long, but if you can do this, I mean, you can copy everything and just run it. Here I call my packages, here I pull my data from a GitHub repository, then I assign this data like a filter, because what I wanted to do here is to show how much time people, I'm very interested in studying how people uses their free time. So I wanted to know how people spend their day. And you can find data for your country as well here in this data set, excuse me. You can see all countries. And I activity. The original graph, including bedtime, was like shrunken down because the lollipop for sleeping was like 8. So it's like we don't need that variable. We want to only center on these ones, on the active ones. And yeah, that's pretty much it. Like an informative graph. You can do the same thing for your country. And the code, it starts here, the lollipop. Here is the colors. Here are the text, theme stuff. And you just need to copy and run this whole thing, and it's going to produce the same graph for you guys. And then you can play with other variables in your data.
Okay.
Back to here. Here is another time series that I made. Oh yeah, you can follow the code here because it's a little bit more complex, because it is a patchwork. Like I combine these two graphs into a single one, but you can follow here and review it eventually. So I tend to use lines and bumps, as you can see here. Lines are very well suited for time series, and this is from the Tidy Tuesday from the 4th week of this year. And they gave us a data set about groundhog predictions. They have this tradition in which a groundhog emerges from the ground, and if it sees their shadow, they are foreseeing like 6 weeks more of winter or something like that. So I want to see how much this tradition, this cultural belief, has been behaving through the years. So in this code here, I'm going to explain again. Here, what the code does is that it loads the needed packages for you to reproduce the graph. here it assigns the data set from GitHub, from the Tidy Tuesday, as you can see here, into this object. And then I use these clean names a lot for any data set that I'm piping through. Comes up with standardized variable numbers or variable titles, excuse me. So that's what this clean names function does. Here's the standardization. And then here is for you to visualize it. So this is the data. I'm going to group my data by year because I'm interested in each year how many groundhogs have been calling through the years. Then we summarize it, and this summary gives us the n variable that we are going to use later on. Then I'm also interested in filtering some data that I saw, because here, as you can see, it stops in 1996. Or, oh no, excuse me, the 2000, because after 2000, this thing skyrocketed. So in the graph, it was like just too much logarithmic behavior. I don't know. So yeah, I stick with separating the graphs in two, and you can reproduce them as well for you guys to see this line. But like time series data is better viewed through lines. So we're almost finishing. I told you about a fun fact, and the fun fact is that ggplot has a lot of different plugins and packages, and I know that sounds very daunting at first, but you don't need to know all these functions. You don't need to know everything that it is to be known, but because it's just too much information. So with the very basic documentation and your own willing to show data in certain ways, you can ask ChatGPT perhaps to help you with finding a better way. I'm going to be honest with you guys. I've been if it wasn't because of ChatGPT and stuff, I wouldn't be able to produce things the way that I'm seeing it in my mind. It's like, I want this graph to be in these ways, in these other ways. And yeah, ChatGPT sometimes makes a lot of mistakes, but it gives you a better to eat dish, if you wish. And as long as you go and review code, you are going to spot the difference. Another very useful skill in R is to don't panic whenever you see an error message or a warning or anything. Just like read what's going on and try to figure out why your graph or why the things that you are trying to do are not behaving the way that you expect them to be. So yeah, it's fun. It is hard work. I'm not going to sugarcoat that, but I have a couple of gifts for you. And the first one is like seeing visual stuff the other way around. It's like, if we are able to read graphs, I think we're better suited for reproducing them. So whenever you see a graph, try to think in these terms. And this is the primary sources guides from the Library of Congress, a very useful resource, I might say, for any primary source like newspapers, photographs, video, painting, graphs, a lot of stuff that we in the social sciences are sometimes surrounded with. This is like a graphic interface training place for ggplot. It's an R package called Esquisse. So you just need to install this, run it. You can look for, well, this link will guide you through how to reproduce some graphs. But what this graphic interface does, it's like it trains you to know which data is better suited for certain type of visualizations. And the cool thing is that if you click in the code tab here, it's going to give you the code, the ggplot, all the R code that you need to reproduce the graphs that you are, like creating with your own hands through this graphic user interface. You might be wondering, yeah, those GIFs are cool and stuff, but why even bothering? Why the hassle of, learning R? Well, it can save you a lot of time because with a single command here, you can watch this documentation here. This is a single command. It's a command called performance. Performance, parentheses, the object, parentheses, and you get all the information for, watching the performance of your model. And the package for doing this is the rstats package. You can follow it here. As you can see, it's a very academic ready, publishing ready graph. Also, another one that is very useful for me is the GG stats plot, GG, as in the other graph that I show you. And as you can see in this violin plot, we have a statistical test on top. We get printed the F Welch for this case, and the p-value and other stuff that is needed, and a lot of very useful information that it's like publishing ready. And this is just one single command, as you can see if you follow this link. That's the GG stats plot. And last but not least, something that we always have to consider is that R is a toolbox for thinking outside the box, making it ideal for the pursuit of science and doing data science the open way, reproducible. Because in the social sciences, that's how we achieve quality, by being reproducible. So it is not the same to hand like an SPSS file with instructions or even with a script, but to having all the transparency over the code of each decision that you have been making to get to that point. So it's very needed, in science. It comes with a very steep learning curve. I'm not going to sugarcoat that, but the reward is huge. And another thing is that our programming is better learned in a social way. So if you guys are interested in joining the community, because that's how we learn, by helping each other, by keeping us motivated, by just being nerds. So yeah, this is a reference, and that will be it from my side.
Okay, thank you, Frederick.